Okay, in this chapter, we are going to discuss, to introduce you to computer networks. What is a computer network? It is a collection of end devices, which are computers and devices, connected together using network devices to transmit data through transmission media. This is controlled by the network protocol. Okay, this is controlled by the network protocol. Okay, the network can be small network or bigger network. Remember, we said we have LAN, WAN, MAN, PAN, personal area network. Okay, they can be connected through cable, phone lines, or wireless links. Computer network may connect computers, printers, and scanners using switches and NICs. What is NIC? Network Interface Card. Okay, through wired and wireless transmission media. The most common protocol used for for network nowadays is TCP/IP. TCP/IP. And this is found used in the internet, is using TCP/IP, even in your home or CCTV networks now. Most of the networks now, they rely on TCP/IP. Network components or the network infrastructure. There are three categories or hardware categories available in the network infrastructure. We have the end devices. If you look on top here, these are samples of the end devices: desktop computers, laptops, printers, IP phones. Okay, and then we have the intermediate devices. The intermediate device is a router, wireless router, LAN switch, routers, multi-layer switches, and so on, or a firewall appliance. Firewall is a intermediate device. Okay, if I ask you, like in multiple choice, or it is an intermediate device. And then we have the network media, like cable, wireless, fiber optic. Okay, so what do the end devices? Let's talk about each one. End device, they form the interface between users and underlying communication network, or end devices and hosts. The hosts send and receive user network traffic. Yani for you as a user, how do you communicate with the network? You talk to the router or to the switch. You talk to your computer. So this is the end device. This is your way of communication through the network. Some examples of end devices we have: computers, telephones, security cameras, mobile devices. This end user is connected to the network through a card. This card is called NIC, Network Interface Card, or NICs. Okay, that enables a computer or device to have networking capability to access a network. The NIC network card coordinates the transmission and receipt of data or instructions and information to and from the computer to the network. Okay. This is a sample of a network card for desktop computer for wired. See, because there is cable. There is a wireless network card, but that one will have an antenna. It will have an antenna here. The intermediary devices, they interconnect end devices with the network. So your end device connected to the intermediary, then to the network device. Very good. The most common intermediary devices are switches, routers, modems, WAP. What is WAP? Very good. Wireless access point. Wireless access point. WAP. Don't forget these names, please. NIC, WAP. Okay. Examples of intermediate devices. Now we have. So here, if you look again, please. Again, look here, please. This is my network devices and intermediate devices connecting to the network. Intermediary devices interconnect end devices, as we just mentioned. These devices provide connectivity and work behind the scenes to ensure that data flow across the network. So they interconnect or connect the individual host to the network and can connect multiple individual networks to form an internetwork. And they can connect multiple networks, like the router can connect multiple LANs. Okay. So we talked about end devices, intermediary devices or intermediate devices, network devices. These are the examples. Then these are some examples, or we talk in details about the switch. A switch connects computers in a network and forwards data frame over the network to the corresponding device in the LAN. The switch is active in the LAN, in the local area. Because the switch has many ports, each port connected to the computer in your local area network. A router, on the other hand, is a device that manages traffic between two or more networks and help find the best path for traffic. The router is higher. The router, you will have multiple LANs connected to it, then it will decide this is going to this LAN or that LAN. When the traffic goes to that LAN, then the switch will decide to which user it is. Like you go to a building, okay, or not. Let's go. You will go. You have like let's say you have a street and there are different buildings. The router will tell you which building to go to. When you reach there, the switch will tell the packet which floor and which user. Okay. Wireless access point, WAP, allows a Wi-Fi compliant device to connect to a wired network. Like here, we have this device here, WAP. Network media. It is a transmission media or communication links. It is the medium through which the data is transferred. Cable, your cable. There are two types of communication links. We have wireless and we have wired. Okay. This is how we put the symbol for the wire. We can have black continuous line or this red, you see this red line. This is for WAN connection, WAN. Yeah. Network models. Now to describe how the network parts are connecting together or working together, we have two types of topologies or diagrams. We have physical topology and logical topology. If you look here, on the left side, this is a, what do you think? Physical. Because it's showing you where is each device is located, classroom, server room. It's physical. It's showing you where are they connected to, or where their location. Okay, it's refers. So physical topology mostly refers to the network hardware and how computers, other devices, and cables or radio signals work together to form the physical network. On the other hand, logical topology, which is this one here, it is more about how the software controls access to the network. So it has the IP addresses, okay, on it. You see the IP addresses? Always on your logical topology. It's always coming in the questions. What is the difference between logical and... Okay, last slide. Peer-to-peer network model. Peer-to-peer network model. The operating system of each computer on the network is responsible for controlling access to its resources without centralized control. So each device can act as a server or client. We don't have a dedicated server. That's why it's called peer-to-peer. And they are all the same power. Okay? This is good if you have a small network or at home, maybe 5 computers. You don't want to buy a server. You don't want to buy an operating system server. It's very expensive. So the computers called hosts on the network form a logical group of computers and users that share resources. Each computer on a peer-to-peer network controls its own administration, resources, and security. Examples of OS that might be installed on a computer in a peer-to-peer network are Windows, Linux, Mac OS, and on desktop and laptop computers. Also, iOS and Android on mobile devices. Okay, they are all examples of operating system for a peer-to-peer computer or host. What are the advantages of using peer-to-peer? Can you tell me? They are simple to configure. You just share and share it with the others. But they are also less expensive. Because if I want to put Windows Server, it is more expensive and it's more complicated to configure. What are the disadvantages of peer-to-peer? They are not scalable. If your network grows, you cannot use it. You have to upgrade to Windows client server. They are not necessarily secure. Okay? They are meant to be for simplicity, not for security. They are not practical for connecting more than a few computers because it is too time-consuming to manage the resources on the network. Okay, so now we will